Hi there, welcome to this lecture about the Quicksort algorithm. This algorithm is also a sorting algorithm. Unlike merge sort, what we aim to do is, given a sequence of n elements, we want to generate a new sequence with its elements sorted from smaller to bigger. Quicksort also follows a divide and conquer strategy, in which on the divide phase, what we do is selecting an element out of the sequence, and we call this element the pivot element, and using that pivot as reference, we want to generate three different sequences. The first sequence, which is the left sequence, will contain all the values from the sequence which are smaller than our pivot. Then we have a second sequence with all those numbers that are of the exact same value as our pivot. And finally, as you can imagine, our right sequence will have all the values that are bigger than the pivot. So then our conquer phase will consist on sorting L and R recursively, because the equal, since all the values are the same as is already sorted, and this will go on until we achieve the case base, that in this case we'll have when the sequence has two elements at most, because in this case we will just order them directly. And finally, the combined phase will be as simple as concatenating left, equal, and right. So if we take this as an example, the first we're going to do is select a pivot. Let's say we take 33 as an example. So now we need to make the three list. Left with the numbers that are smaller than our pivot. That means we go element by element. 55 is bigger, so the first element would be 22. 55 would be on the right one, 22 here. 44 is bigger, so we place it here. 66 is bigger, we place it here. 11 is smaller, we place it here. 33 is the same as our pivot. 22 is smaller, we place it here. And finally 66 is bigger, we place it here. That one is already sorted, we need to sort the other two. So we go again. Let's say that now we use 11 as our pivot, so we will need to build the three list. A smaller list, in this case our pivot is the smaller value, so there would not be any left list. The list with the values of our pivot, and the right list. And the same with the other list. Let's say we select 66 as our pivot, so we are going to create three lists. 55 is smaller, 44 is smaller, 66 is our pivot, 66 is our pivot, and we don't have any right one. So now we go on again. Here our list, or sequence of our list, it doesn't matter how to call it, it contains exactly two elements, so we can, it's our base case and we can sort it directly. And in this case it's already sorted as well. There's no more numbers to sort, so the other two sequences, we have this sequence, we need to sort it, so in this case would be 44, 45, and remember the pivot is already sorted, So now what we want to do is the combined phase. Remember, combine is always left equal right. So that means in this case there was no left value. So we go directly to combine the equal value and the right value. And here the same. Left equal, and there was not right value. And finally, then the missing step, this is the left, that's the equal, and the right. And with this, our sequence is sorted. Now, if we pay attention to the cost of performing this algorithm, we can compute that our best case would be n log n, but the worst case scenario has a quadratic cost, which is a little bit more expensive. This is due to how we select the pivot, because until now we have selected it randomly, but how can we improve the algorithm? By selecting the pivot with a little bit of a strategy. One of the best ways to do it would be to compute the median of the sequence. However, that would also be expensive. So what we can do is, instead of computing the median of the whole sequence, we can compute the median between the first element of the sequence, the central element of the sequence, and the last element of the sequence. So if we go back to our previous example, what we are going to do is to compare those three elements, first, middle, and last, and select the pivot out of them. To do that, what we do is sort the elements. In this case, they are already sorted. 55, 66, 56, and select the middle one. Therefore, our pivot in this case would be the value 66. So then, from now, we proceed on the same fashion. The numbers that are smaller than the pivot, in this case 55, 22, 44, 66 has the same value, 11, 33, 22, and 36, and we don't have a right list. Here we do again, out of this 55, 1, 2, 3, 4, 5, 6, the middle is 44 and 22. We sort the three of them, that would be 22, 44, and 55, and the middle value, which is 44, which become a new pivot. And from there, we do the same. 55, it's bigger than 44. 22, it's smaller than 44. 44 equal to 44. 11 smaller. 33, 22 smaller. And we go again. In this case, this is already sorted, so we don't need to do anything more. And from here, we select out of the middle, out of these three, we select the median. If we sort it, it's 11, 22, 22. The value in the middle is 22, so we select 22 as our pivot. and make 3 lists. 22, that is our pivot, 11, which is smaller, 33, which is bigger, and 22, which is the pivot. Then, since L and R contain a single element, they are already sorted, then we can move on to the combine phase. Remember, combination is left equal right, and we go back up. Remember that we are in this subtree, so now we would go on that direction. That means this is the left sequence, this 44 is the equal sequence, and the 55 was the right sequence, and we go back up, which in this case, since there was no right part, then would be simply adding those numbers at the end. And with this, we have our sequence sorted. How can we implement this? So again, the simple way is using an auxiliary recursive function that takes into account the position of the first and last element of the list, as always, making the first call with the start of the list, the end of the list, and then what we're going to do is use another function that will compute both the pivot and the unsorted, making what is called an in-place function that will be updating the values on the original list, and we will return the position of the pivot that is needed for doing the recursion. That's all. Thank you.